Hi, everyone. I'm going to talk about an approach to frontline software supply chain security. The material is pretty high level, conceptual overview intended for anybody who wants to figure out how they can secure their software supply chain in their organization, build a comprehensive automated supply chain security program, and simply ship more secure, less risky applications to the prod environments and their customers. I refer to the approach as the 3 S's of software supply chain security. Software supply chain security has become a top-of-mind concern over the past year. The reason is there have been a number of high-profile attacks, breaches, and exploits directed at the global software supply chain. These made headlines due to their massive impact. The much-publicized SolarWinds attack, Log4j, these are all prime examples. These occurrences seriously strained our ability to respond effectively. They shined a spotlight on the risk of future attacks and raised serious concerns about how we secure the vastly complex global supply chain that underpins all of our software. In an age when every company is a software company, this is a risk far too great. Software developers, security practitioners, open source foundations, governments, industry-leading companies have scrambled to create new solutions and approaches to addressing this risk. But we are in the very early phases of realizing and implementing these solutions widely and effectively. The software supply chain is a pretty cool modern marvel. Free and open source software has proliferated, and it's easily used and applied by millions of developers today. The speed of digital transformation and software innovation continues to increase exponentially as a result. Likewise, software supply chain complexity, scale, and risk increase proportionately. Today, it's really easy for developers to incorporate vast libraries of code into their applications, package all that into containers, and ship that to production with the click of a button. Code running in production is the child of the massive supply chain that birthed it. It bears the benefits and risks of all the decisions, contributions, features, and flaws manifested by its creators in aggregate. Kelsey Hightower said in his popular parody GitHub project, No Code, "No code is the best way to write secure and reliable applications. Write nothing, deploy nowhere." This idea is so relevant today in an age where it's common to ship so much code to production so fast and with apparently so much risk. It begs the question, do we really know our software? Do we know how it was produced, secured, and handled? Can we trust the authors? Do we trust that the software is authentic? Is all the software we run in production applications really needed to do the job? The 3 S's seek to address these important questions about the software supply chain security and the integrity of the software we run. The 3 S's are the first letters of the words SBOMs, signing, and slimming, and they represent key concepts in managing software supply chain risk. The first S is for SBOMs, software bills of material. These are lists of all the components in a piece of software with special focus on open source and third-party components. SBOMs are necessary tools in the quest to know your software. The second S is for signing. Signing is a way of digitally attaching a verified, immutable developer identity to a piece of code. Coupled with other tools, it allows for creating a transparent, cryptographically secure record of software changes and manifest in a permanent and reliable digital chain of custody for software and related artifacts. And the third S is for slimming. Slimming is the process of minimizing the code footprint you ship to production in the form of containers. This inherently reduces software supply chain complexity, software attack surface, and the aggregate risk of the software you deploy. Let's talk about SBOMs. First, SBOMs are an important basic tool used for describing a body of software dependencies. They're produced using software tools that inspect software repositories and containers to produce a digital record of the packages and components they comprise. SBOMs can be aggregated to represent an arbitrarily large collection of software dependencies. They are the definitive software recipe for the code that you manage and deploy. SBOMs are machine readable in any of several standard formats. Once your software is described by SBOMs and stored, you can continuously monitor the dependencies they represent for emerging vulnerabilities, patching, and other supply chain related risks. SBOMs are required for any vendor selling software to the US government by executive order. There are pros and cons to using SBOMs. The pros are they help you know what's in your container, they provide a nutritional label for the core components, And it's also an inventory you can use for continuous assessment and improvement. It's machine readable, so systems can work on these records to automatically process them and help you improve your software supply risk. The cons, this is kind of a reactive approach. It doesn't happen until after you know what's already in your packages. Maintaining these records can be difficult because they get large over time, and there can be inconsistency between various tools and how they interpret them and how they produce them. The second S is signing. The purpose of signing is to provide cryptographic proof that the author of a piece of code is who they say they are, and that the code hasn't been changed or corrupted since it was committed and signed. If a piece of code is changed, the change is signed, and the author of the change is made known in this record. The concept extends to any automata that build and process software. In an end-to-end system, signed code and artifacts are recorded along the supply chain in a transparent record. Downstream systems that build from signed software programmatically interact with this record to ascertain the integrity and provenance of that software. This pertains to the full extent of the contributing upstream dependency chain, assuming the record is complete and intact. In the future, we will rely on signing and related systems as a root of trust for all software dependencies. No software will be consumed, deployed, or run where provenance is ambiguous or unknown. Significant adoption of these kinds of technologies will be required to reach this reality. Today, the adoption of such systems is described is low and components are nascent, but momentum is building. Two primary signing systems that are available today are called Sigstore and Notary, and these are available through various open source projects and in tools that are available today. The pros and cons of signing are that on the pro side, this is a future possibility for a trust foundation for all software in the supply chain, so that you can establish provenance of your containers in your system, which really helps you be certain you're running the code that you expect to run and that you can trust it. New tools are certainly making it easier, and we see that this is gaining support in a lot of major platforms, including Kubernetes, GitHub, and AWS. On the con side, trust doesn't naturally imply need. Just because you can trust code doesn't mean you should be using it. There are all sorts of risks that come along with any code that you might run, including the future prospects of vulnerabilities. Alone, it doesn't necessarily prevent vulnerabilities like Log4j or bad actor risk that's caused by a previously trusted actor modifying code in a way that's malicious. Revocations and changes along this transparency record can be hard to manage, and it's uncertain today which standards will prevail, but there are some leaders in the clubhouse. Slimming is the third S, as I mentioned earlier. The safest software is the software you never ship. It's important to be sure that you are only running code in production that's required for your app or service to function properly, and no more. On average, it's typical today for organizations to deploy containerized software to production containing significant amounts of unnecessary software waste in the form of libraries, operating system binaries, tools, package managers, and more. Shipping and running unnecessary code is costly, less secure, and increases the operational complexity to maintain your production software footprint. The more code you ship, the larger and more complex is your effective supply chain. Removing software from container images has historically been pretty manual, labor-intensive work that requires specialized expert knowledge. By contrast, slimming programmatically and automatically removes unnecessary code from production images during the CI/CD build phase of production image creation. Slimming containers has multiple significant benefits that include reduced vulnerabilities, faster CI/CD cycle times, runtime efficiency, lower deployment times, operational costs, and reduced software risk surfaces. This is a significant developer experience benefit from slimming as well. Since slimming occurs in the production build phase of a container lifecycle, developers are free to use images locally that best suit their experience, velocity, and productivity. These development images may contain libraries, test suites, tools, package managers, etc. The slimming process will remove these artifacts later to produce a minimum production-ready image. There are pros and cons to slimming. On the pro side, slimming can easily and automatically reduce the size and attack surface of containers. Along with this, vulnerabilities get removed, supply chain complexity and risk are diminished, and there are added benefits to performance and cloud costs. The cons, if this is done manually, it can be complex and quite expert process to make all this work, which means more work for developers and requires good test infrastructure to automate slimming effectively across an organization. So I mentioned the three S's and their impact and the means by which you can start to approach using them and understand them in your environment. Our container best practices that include these ideas of slimming, signing, and SBOMs really culminate in 5 key points. 1, to be able to reduce supply chain risk, you need to, 1, control what's inside your containers. And it's really being able to manage and understand what you're shipping to production and all of the code that you use in your organization. Minimize image size and optimize for build speed. Make sure that your images are containing only the software you need. This reduces your supply chain complexity and risk, but also has many operational benefits. Be sure that you control vulnerabilities and secure all the services that run in your containers. The 3 S's help you do that. Slimming is a key component in that. Enforce these standards across your organization and make sure that you automate change management so that you can be sure that you have a continuously adapting and continuously evolving security program for any software that you use. The 3 S's are possible today in several forms. We'd love to help you figure out how you can